Good afternoon, Topconf. I'm so glad that you are all here. And how was the lunch? Was it good? Yeah, very good. And my name is Michal, and I came to you from Poland, from Krakow. And I work in Luxsoft as software quality engineer. And I do everything that is needed to deliver with quality. Most importantly, making sure that the quality is in entire process as and it is in people's minds. So it's not just about testing. Moreover, I'm a trainer in Luxsoft training. I teach people Agile and Java. That's what I do. And my presentation is about BDD, Groovier, and Spock in that order. So enough chit chat, let's begin. This is typical product by Apple. Just one button, white cover, and desperate people sleeping on the streets in front of iStores just to get one. This is typical Google product. One text box, one button, and billions of queries every day. Billions of dollars of revenue every month. And that's the application that we work on, most probably. A lot of weird logic, buttons, mess, complexity. Do you recognize it? However, even if those apps are looking complex, usually it's not a rocket science. Our apps contain just a lot of ifs, loops, data processing, and usually that's it. So majority of our apps can rely just on algorithms that were written previously before by someone else. It's not the hardcore algorithm hacking as it used to be before in the old days. So we could say life is simple, yeah? However, we all know that picture. I won't be going into details. So it appears that we have issues in our daily development. However, it all boils down to the thing that the biggest problem is to understand the problem, the essence of the thing that we are trying to build, to deliver. And that's a key thing. So who knows the way that we are going? And I call people that know it business guys, those strange creatures that are not thinking in terms of code about the present, but they are looking much forward into the path we are going. They see us reaching the goals that would guarantee the success for us. So, solution is simple. Just follow this path. Just make sure that we are going towards that goals. How to achieve it? Of course, by some kind of verification that what we coded works. And some people, they struggle so much with Java that whenever they see the project just compiled, the class they wrote is correct, all semicolons are matching and brackets are fine, they are so happy that wow, it works. However, we are all responsible people and we have tests. Otherwise, you wouldn't be here with me. We all have tests, especially unit tests, that verify if what we coded works. There is one more level, which is test first, where we just have faster feedback because we can try out the things before we even create them. And the ultimate level is TDD, where we have this heavy refactoring stage where also our design emerges naturally out of our tests and our code. And the first framework to do TDD was SUnit for Smalltalk. But Smalltalk was very quickly replaced by other languages, and majority of those languages already have their own XUnits. So we have NUnit, DUnit, PHPUnit, and most importantly, JUnit, that for sure you all know it. However, there is bad thing in that JUnit, which is unit in the name. As TDD is not about unit testing, it is about testing. And just unit testing is not enough to verify that all what we did worked correctly. And TDD, as it was proposed originally, it was supposed to operate on multiple levels of abstractions, not just on our classes or small units of code level. So at some point, Dan North had to come and said, guys, you are following the wrong path. It's not only about those technical low-level tests, but you need to have proper tests on all levels. Most importantly, those high-level tests that would serve also as a living documentation. And he reminded all people that those tests, high-level tests, business tests, or acceptance tests, however we call them, they should be understandable to developer, and that's very easy because we are all smart guys. We understand what non-technical people say to us. However, the second point is harder. So our tests, our documentation that verify our apps should be understandable to non-technical people. Of course, it should be unambiguous for everyone and automated and run frequently so that our app fulfills those goals not only right now, but it is going towards that direction in a stable manner. And he used Gherkin language to create such specification that would be understandable for both sides. And this language is super easy. It has just 3 keywords. Given, where we set the state of the word, we have when, where just actions in our system happens, it stimulates our system, and also then, where we just perform assertions that what we call that works. That's it. He also proposed JBehave framework to do it. So he came up with ready solution. Just you can use it and you already have this conversation with business. So JBehave framework consists of 3 main blocks. One is plain text files that just describe how our system should behave. Here we have example of vending machine. Then we have Java code that just matches those lines out of this plain text file by notations with the implementation. And this is kind of JUnit. And the only difference between JUnit and JBehave is that JBehave is driven, order of invocation of this code is driven by JBehave, this plain text file, not by this test annotation. However, underneath it's just JUnit, and you can do almost everything that we can do in normal JUnit. So we just drive tests by plain text files. And third part is the ugly part, it's configuration. We need to configure it in code, and it's horrible piece of code that you probably need to have somewhere just to make it working, but you do it once. So it's not an issue. So when I joined my company, JBehave was advertised to me as a great tool. So we do BDD. We use this coolest, trendy framework that Dan North proposed, and we are the best agile developers because we use it. However, then I was talking with people separately, and I realized that they do not like it. They actually hate it. They hate to write anything in JBehave. And it was a surprise for me. So you are not happy about this coolest thing possible? And apparently no. And so I've recorded some issues those people were complaining about. So they were saying that it's twice as much files to maintain. When you have just a test, in JUnit you have 1 file, but in JBehave we have 2 files that ideally need to be modified at the same time in split view, so we have twice as much things to handle, twice as much changes to be done to modify something. Then, as Java developers, we like automatic refactoring. So we press Shift F6, and we want everything to be changed in our project. However, this doesn't work for JBehave. So we cannot just rename our plain text file and the code gets fixed. So we needed to do it manually. It's just painful. Overhead connected with that just makes not convenient to do everything in JBehave, because we need to do so much work. So we use it only for the highest level tests. According to parameters, you should have a low amount of them. Yeah, so we can have this overhead just for some tests, but all the other probably are using just JUnit. Then those story files, they look nicely on examples like I was showing you, but whenever we have more and more logic in our system happening, they are becoming dull and unreadable. So for sure you don't see what's here, and that's on purpose, because it's how they look, both for developers and for business people. It's just something that looks ugly. Then, in order to achieve type safety in Java in this glue code, we need to transform parameters that we provide to our tests, and this is work for monkeys. So, for example, that's a class that is needed to be implemented if we want to parameterize our test with true and false. So that's a code in Java that translates string true to the proper Boolean object, and the amount of glue code, like boilerplate code, we need to provide to have this JBehave running nicely. Then those steps from plaintext files are matched with those annotations using greedy regular expressions. So if you have more and more steps defined, and you use many like various parameter replacements, then it appears that you need to have this regular expression processor running in your mind in order to comprehend how those steps from the plaintext files are matched with the Java code. So it's getting more and more complex. So it appeared that in my environment, only developers were creating those story files. So the original idea of Danor was that everyone can create them. Like analysts, like non-technical people could sit, write story file, and then developers would just automate it. However, those business guys, they like to use nice language. And we ended up in a situation where the same step, essentially the same operation, was written in different wordings because it looked nicer. This creates proper sentence, this wasn't, and so on. So we ended up having lots of aliases for the same step. It was just causing maintenance issues. So the solution was just give it to developers that they know how the tests underneath were implemented, and they will create proper descriptions that would be unambiguous, and they will really say what this test does. However, they hate it. Even the bigger pain was that those people were not reading those story files that were created specifically for them. They were not interested because of this, dulliness, this amount of plaintext file that they were not interested in. It was just the presentation layer of those examples, specification by example, was not good enough. So that we realized that we are misusing the tool. It doesn't make sense to use this JBehave in such situation. Just overhead, and people were telling, okay, this BDD is a crap. Total crap. We are developers, just do normal tests like we do on all levels. So the idea was just to use JUnit, yeah? It has unit in a name, but let's use it for all tests. Yeah, if this JBehave is just overhead and no value added. And if we want to apply still those BDD, principles, we can have comments in those JUnit tests like even when then. We can have very nice names. Should do something when something happens, as Danor recommended. So on, so on, and so on. Even if we don't like comments, we could have method names that start with given when then. So there are many ways how to convey this style of testing in just JUnit. And this is one example of such test. So we are again on this vending machine example. So I created to prepare some fancy example. example. So we are using, as you see, some immutable collections. We are using final fields. We are using great Ham crests, readable assertions is equal to. We are creating some three-dimensional array of bills that then is assigned to two-dimensional array of objects and returning as collection of arrays of objects. And this goes as parameters to the test, just to verify that our vending machine, when we insert those coins inside, works correctly. And there is one issue with it. So much code just to cover this thing. So you may notice that majority of it is just a noise. Just a noise that we need to filter out to get the business context out of those JUnit tests. We need to, filter out 80% of content just to get to the signal. So signal to noise ratio is poor. Moreover, all of such tests are set. And I would say they are very set, especially if you use Hamcrest matchers. Oh yeah, so what to do with it? JUnit Jungle. JBehave has its disadvantages. What else? And we have Groovier language that we notice that might be useful to solve our issue. Just very brief introductions. Who of you knows Groovier already? Like half of people. That's great. I will just go quickly through its most important features. So it's dynamic language by its nature. However, we have a freedom to make static type checking and even static compilation if needed. So we have full control over how this type checking and compilation is done. And actually, Groovier is optionally and strongly typed. You may think it's contradiction. How something can be strongly typed in dynamic language? What does it mean? And that's short explanation. What is difference between strong typing, statical typing, dynamic typing, and weak typing? Because those are distinct. Java, of course, is strong and static. So if we try to divide integer by string, it doesn't compile, we get error to our face. Not possible, mister. Then C++, which is, as you know, statically compiled. However, we can do magic like we can cast string to some integer value, which would be memory address, and then do the division, and we get 0 out of such computation. So some weird stuff can be going on by casting. So C++ cannot be called as a strong type because we can change the type in runtime. Then JavaScript. What's the result of that computation? Don't talk. However, it's very intuitive. It's just half. 0.5. So it works. You can do crazy stuff, and casting is performed dynamically, and it's not strongly typed. You can change types however you like. What type is the answer? It's just integer. Yeah. In Groovier, we have more freedom. So by default, it's dynamic, so we can perform such division. It will fail in runtime because it's strongly typed. We cannot do such division because types do not match. And IntelliJ, by default, it would warn us with such warning. OK, this is going to fail. However, we may have annotation type checked that just make our code not compiling. So we have a choice. We can choose what style of coding we like. And half of you said that you don't know Groovier. So already you know Groovier, because you can just continue writing Java and rename file from Java to Groovier. And you are Groovier developers. If you use IntelliJ, actually there is not much that needs to be done. Maybe you need to configure a Gradle at one plugin, or in Maven, just a bit of config. And you code in Groovier in your existing Java projects. Very easy. So Groovier code is just an extension of Java. And it has a lot of interesting features. I won't be going through all of them, but there is a lot of sugar added to Java. So if you complain that Java has this hard, and that, probably it's a bit better in Groovie. For example, it has nicer syntax for map and list, and it's probably not going to happen in Java ever. So recently they said, we are not going to have this native syntax for collections. We'll have some factories in Java 9, but that's it. Math is precise by default. So in Java, you may be surprised if you invoke such calculation. You will get some non-precise double number 009s, and out of second division is just 1. In Groovie, it's just intuitive, so those operations are on big decimals. It's even more object-oriented than Java because primitives do not exist, and we can invoke one.class simple name and get integer. So it's fully object-oriented. Even null is an object. And most importantly for our purposes, in Groovie, a lot of syntax is optional. So we can reduce that noise that we have by not typing semicolons, omitting parentheses when it's obvious from the context what are parameters, and even we can skip some dots when chaining method calls. This is pretty powerful because we can translate such typical Java chained method and parameters call to sentence that would be also correct in English language. We can order coffee with milk, chocolate, and sugar as we do in English language, as we write it. This syntax is so powerful that we can provide map parameters that would give us colon, and we could create sentences like, check that Groovie is readable. And I can also say to you guys at Topconf that Groovie is awesome by having such syntax. Very powerful, pretty much as it would be in English. All right, so we have language that looks promising. How to create tests in it, verification. And there is Spock framework. It advertises as enterprise-ready specification framework, so probably your corporate environment would accept it for testing all JVM apps. So it's not only about just Java, Groovie, but also we can try to use it in Kotlin, Scala, whatever we like, especially for those high-level tests when we do not test like just individual classes. What about the name? So forget that you've seen that guy. Original author Peter Niederwieser says that it's just connection of spec and mock, just to suggest us that it can be used for very high-level test specifications and also low-level mock involving stuff. The first thing that Spock does, it changes the words we use. So instead of having this classical SUT, system under test, it promotes approach where we say system under spec, SUS. So everything is specification of our system. So the advice is that, okay, probably it will be more readable like normal classical spec. Spock tries to use all that Groovie goodness. It is easy to learn just as Groovie because it doesn't have actually any specific API, maybe a couple of methods, but that's it. It is based on JUnit, so whenever you have all your JUnit tests work in your CI environment, in your Maven, Gradle, IntelliJ, NetBeans, or whatever, they will be working exactly the same because it uses like JUnit underneath to invoke those tests. Assertion APIs is all based on operators, so there is no need for this Hamcrest, AsserJ, because all is built into language. Even gives more interesting detailed failures. API on mocking is also based on these operators, and there are many conventions, so we don't need to annotate every testing method. So we see that we have this reduced noise. Whenever we perform assertion, it gets entire line and prints what were the values, so we get the context of failure. So you may have encountered that issue that if you use this fancy, assert.j with the latest version, and the only thing that you get in your CI is like 4 was not equal to 5. And what does it mean? What was the context? What was 4 supposed to represent, and what was 5? And without, explaining that assertion in separate sentence, you don't have this context. Why Spock does it automatically for you? It prints you entire context of such assertion. So all in all, we can just focus on specifying behavior. We can focus more on our domain language in our tests. So that Spock is more like testing language, just a framework. So we can create our own testing approach using Spock. And this is suitable for all kinds of testing. So whatever you like, TDD, BDD, component, unit integration, test last, test first, acceptance system, everything is fine in Spock. No issues of handling of any of those types. Let's go into the code, how it looks like. Not that complex. This is very familiar to you as Java developers. We just provide any suitable name for our specification, and we need to extend base class, which is specification. This is already our test base, and then in this specification we create feature methods that are just our test cases. And first advantage over Java here is that we can omit the return type, and name of this method can be any Unicode string. So we don't need to use camel case anymore. I know that you are the most proficient in reading camel case in the world, 10 times faster than normal human being, but still, we can use, for example, proper interpunction or casing in our test names. Question for you, does it compile? Is it valid Java code? Yeah, so you already know. And if you don't know yet, this is a hint from IntelliJ that we'll give you with syntax coloring. What it says, this is just a comment, and the first part is, in this case, unused label. Do you know that feature of Java that we can have labels? And we can have labels anywhere in our code. They will be unused, but it's still valid compilable code. And that's the feature that Spock uses to our different parts of our test. So we have given, when, then stage, as done or recommended, and also where section where we just put parameters as tables. Also, we can have shorter form of when, then. We just have expect, and here we can perform both assertions and actions to our system. And this is how we parameterize our tests. So if you compare it to this JUnit parameterize, which is so nasty, this looks beautiful. And this is not just a plain text. This is living code. Of course, underneath those are just operators that are overloaded, binary operators. But IntelliJ understands it enough so that it can infer those types and pass it to the test invocation. We even know that here A is integer, and we will get all the code completion that out of this context, A in this table is integer, and that would give us on failure very meaningful result. So we try to have max out of 7 and 4, and we expect result 8, which is of course not. So we see the proper context why our test failed. There is still one ugly thing in our case, and those are these names of like numbers of tests. So we had 3 parameterizations, and we don't have proper names for them. Well, this is where unrolling pops in, so we can parameterize our test names just to get even more readable test reports. And a couple more features that would be useful in our context, which are annotation, that we can provide full Unicode name for our tests, if we don't like this camel case for those. We can annotate what we are testing, what is our system, if we have many fields in our class. We can put narrative that would be natural place to explain whys of our code. Why our system behaves like that. Why we need that feature. Just give a context, because JUnit, traditionally, it was only about how our system behaves. Just when we put the data, this is a response that we get. But the more important thing that usually is lost, just was initially in people's minds, but then forgotten, is why the system needs to behave in that way. And that's very good natural place for such info in Spock. We have annotations like issue and see that we can also provide a hint where is additional context for our tests. And also it has even better test-first support than JUnit, because in JUnit, what we can do if test is not yet like implemented in code, we can annotate it with ignore. It means that test wouldn't be invoked at all, while in Groovier there is not an implemented annotation, which would make sure that our test is failing. Because in Java and JUnit, what happens is that you have ignored tests and they are ignored forever, even if they are already implemented, and no one notices it. While this annotation makes sure that whenever the test finally gets implemented, it will start to fail, informing us that we should remove this annotation because it is already implemented. So nice way of support for this high-level test-first support when we do not have final solution for our test scenario within a couple of hours or even days. It also comes with nice support out of the box for exceptions. So we are encouraged to not only check sunny day scenarios, but there is syntax thrown just to verify that some exceptions are expected, and also encourages us to verify those worse scenarios, rainy days ones. All right, so this is just as it was in Java, however, with this optional syntax and assertions based on operator API. However, if you want to make it more readable for non-technical people that cannot read such code, we need to provide those textual descriptions, like it was in plain text file in JBehave. And in Spock, there is place for it. So we can join this plain text file with our code, just to have it immediately right next to each other. So we provide textual description and just below it code. So you see we reduce this coupling between the files. Now it's just one file, and essentially we have the same results. We can even generate reports like JBehave does. So those reports get those textual descriptions, and they just generate whatever we want, whatever documentation for whoever needs it in the customizable way. So we can even create Markdown if we are GitHub lovers, just to present in for our audience. And some business people, like in our case, love Confluence. Some of you may meet, I know, Word lovers, and it's still possible to generate, doc files out of it. So just the idea of BDD is to reach your person, whoever it is. If it's technical, then perfectly fine. You don't need it. Yeah? But if your person that sets goals for you is non-technical, then you need to reach it in proper, best suitable way. However, we noticed that there is some amount of duplication in that approach. As I was showing you, this is saying the same that is done here. So it's still dubs. So developer needs to write, first of all, code and then explain what it does. And in our system, we noticed that what we do is quite repetitive. So our high-level tests just put messages to our system, and they expect some other messages that are coming as a result. So we applied those optional syntax. We played a bit with our test-based test classes, and it was made possible. So such syntax, just to create messages, then put it to the system and make assertions on the reports, were becoming more and more readable, even for people that couldn't understand code, just non-developers. So if you see it out of the context, of course, there is some parentheses, there is some dots that looks a bit like a code, but if you try hard enough, you could read perfectly fine what this specification is about. And we invested even more. We learned how to use this optional syntax, how to omit those dots, how to use some Boolean operators that are given in Groovier. And by applying that knowledge, we created something at some point that was very similar to these plain text files. So instead of having this duplication, we reached a moment when just playing with Groovier, exploring new Groovier features, because every day you work in Groovier, you learn something new. We created our tests that were direct equivalent to our plain text files we had before. However, this was all code. This was code, Groovier code, and this was plain text files. So difference is minimal. If you present this for external reader and this information conveyed is the same, and form of information is almost exactly the same. Well, this is one file, this is two files, and many benefits coming with this Groovier syntax approach. So finally, refactoring works as it does for Groovier, because that's just a code. We can apply even static analysis for this, because this is Groovier code and there is code narc to verify it. We get syntax coloring for free for those specifications, and this is how it was looking in IntelliJ. And generally, information was the same, but the presentation layer and the maintenance of it was much, much better, and my team was having a lot of fun. So instead of hating those JBehave plain text files, we started to love it a lot, this approach. By reducing the application and reducing maintenance cost, we made it possible and made it live. And as I said, our business people at that moment, they really loved Confluence. So it was pretty easy to take such Spock test that had proper title, narrative, and some steps in the syntax that we created, and convert it direct to the form that was most suitable for them. So we applied some, nice colors, some even, winding up this specification by example if they were not interested. We applied some, formatting just around it, and immediately this BDD by the book, as Dan North proposed, started to work. So solution for us was make developers happy to do it, and apply colors, formatting, and proper presentation for business guys. And it all started working automatically, and generally situation in projects started to improve a lot because the business people started to read it, understand, and they were finding issues in the system. We just had conversation as it should be. So few lessons learned. The less layers and less translation we have, the better. So it's better to reduce the application so that our ideas do not get lost into translation across many layers. We can create the DSLs by ourselves. We don't need to treat domain-specific languages as something that is given externally and we cannot do our own. We did, and we, from the stage where we didn't know Groovier at all to the stage where we had our own DSL, it took, I don't know, maybe 2 weeks, not longer. And it was very nice domain-specific language for our app that was providing benefits already. So I know that Danor was saying that those specifications should be created by everyone, by whoever. It should be shared. But I think that it still could be working even if they're written by devs. And this Groovier approach requires those to be written by devs, as this is code. Non-technical people won't be able to create those Groovier files. However, developer is super proficient in it because it has code completion. It presses control space and all possible steps that are applicable can be chosen. So much more proficient than just normal plain text files. So it can live without our application. And also just leverage the goodness of tools we have and choose the proper one for the problem. Always try to look for the improvement. However, most importantly, do not forget that the most important tool is just our brain. That's the idea here. Thank you very much. That's it. Do we have time for questions? Yeah, go on if you have some. Yeah.
Question. You showed a slide where a message was sent to the system
yep.
and a report was generated. What does that mean? How does it know that a report was generated?
Right. So underneath, it was just a code, Groovy code, that was verifying that the report was generated. So it was polling the queue out of our system every second and checking whether a message have already arrived. And if it arrived, it took that report and performed assertion on its status. So it's just normal code. It can be written in Java. Only there was very thin layer above it to create this DSL, but underneath it was normal testing like you would do in any language. So no magic at all. So indeed you have more layers underneath, like in proper high-level testing, that you do not put implementation details, how you poll that queue to the end user of that test. Okay, thank you very much. Yeah, yeah.
How do you get the last example that is sent to the business people? Do you manually convert that, or is it automatically converted?
We were converting it automatically, but by our own parser.
Okay.
So,
two equal signs and change it to something like is equal and things like that.
Sorry, can you read?
So it took like these two equal signs,
yes.
Change it automatically to phrase is equal and things like that.
Yes,
okay.
It was done like that. So we created our own parser that was taking these Groovy files to make it such form. So if you're people that read those specs are fine with equals and they can read it, then do not it. It would be even simpler. But our people were totally non-technical and they wouldn't know what equals. So we just created string replace all equals with is equal to. So very simple parser. It took us a couple of hours to write it and generate that Confluence page. But it can be whatever according to your needs. Don't forget to rate my presentation. I'm waiting for a feedback. Thanks a lot.